we need to know is, by the nature of a given function, we can easily know that this function has a maximum value or minimum value by the way the function has been given. So now, how do you know that this function will have a maximum or minimum value? So if your function whose coefficient, or if your function whose highest power has the coefficient of a positive or negative, this part is the one that indicates whether our function will have the maximum value or minimum value. So what I mean is this. For example, this function f of x is equal to 2x plus 4x minus 5. In other words, you can write y is equal to 2x squared plus 4x minus 5. This and that are one and the same. So now the first question is, does this function have a maximum value or minimum value? All right, does this function have a maximum value or minimum value? So because our coefficient of x squared is positive, hence we're going to have a minimum value. We're going to get a minimum value. All right, and of course our graph, if we're to plot this, will have a smiley face. Our graph will be of this nature. Okay, our graph will be of that nature. Now, if we had a negative there, that means we would have had a maximum value and our graph would have been the opposite. Instead of being like this, our graph would have turned out like that. Okay, so this is how you determine or know which one is a minimum, which function has a minimum value and which function doesn't have a minimum value. So you can actually tell by the nature of the given function. So let's say, okay, how do you determine the turning point? Because now our graph has a turning point. So in this case, this is our turning point. And there is our turning point. All right, so by turning point, I'm talking about the point where a parabola turns the minimum or maximum point of the parabola, like the way we did. So it might be going this direction, then when reaching this point, it starts going up. Or when it goes up, then when it reaches this point, it starts going down. That's why we're calling it a turning point, where the curve turns. All right, it was going down, then it picks up. It was going up, then it goes down. Okay, so how do we find the turning point? Using the given function, how do you find the turning point? Okay, so a standard equation of a quadratic equation is in the form of ax squared plus bx plus c. All right, so if we're to get the data, our a, it will be 2, a is 2, and my b will be 4, and my c will be negative 5. I need this information when finding the turning point. Then this turning point has a x-axis and y-axis. As x-axis and y-axis as those coordinates. All right. So for me to find the turning point, I need to know the turning point of x and y. I need to find those coordinates that makes this curve to turn. Hey, Ballista Noel. Good to see you, Noel. Long time. Good to see you. Happy to see you. Okay, so now how do you find the turning point? So for the x-axis, because now I've said that the turning point has x and y. Okay, so for the x-axis, our turning point can be found by x is equal to, or the coordinate for x can be found by x is equal to negative b over 2a. That is for if you're finding the coordinate for the x. And for the y, we use the same. All right, for the y, we use the same function that we have been given. So in other words, we use this when finding the coordinate 3 for the turning point for y. So now let's go. We're going to say x is equal to, our b is what? Is 4. So we have negative 4, open bracket, 2. Our a is what? Is 2.